Hi, everyone. My name is Maggie Jones. I'm a PhD student with Doctors Bob McCleary and Rob Fletcher in wildlife ecology and conservation. And today I'm going to be talking about the combined effects of mega-herbivores and drought on the loss of large trees in African savannas. The African savannas provide a unique opportunity to study the interaction between top-down and bottom-up forces in shaping vegetation patterns. Savannas are characterized by a heterogeneous woody canopy cover with sparsely distributed large trees. And this structure is generally thought to be primarily controlled by consumers, so herbivores and fire. But we know that bottom-up forces like climate and soil can also influence these vegetation patterns. But what we don't understand as well is the interactions between these top-down and bottom-up forces. So that's really what I'm interested in here. Specifically, I'm interested in the interaction between drought and mega-herbivores on large savanna trees and how they shape woody vegetation structure. So the goal of this study was to assess the interaction between drought and mega-herbivores, particularly African elephants, and compare changes in large tree densities before and after a severe drought in a savanna with elephants to a savanna without elephants, with drought and elephants being significant agents of mortality for large trees in savannas. We expected to see a synergistic effect of elephants and drought, where both would lead to large tree mortality. But when combined, the effect would be greater than expected because of a shift in elephant foraging to include more woody material during a drought when grass is less available, and increased vulnerability to herbivore damage for these drought-stressed trees. Alternatively, we could see additive effects if drought and elephants have independent influences on these trees, or antagonistic effects if drought or elephants reduce the impact of the other stressor on these trees. We conducted this study in two sites, one in Kruger National Park in South Africa, and the other in Hwane Royal National Park in Eswatini. These sites are very similar, except that in Kruger, there's a high density of elephants, whereas in Hwane, there are no elephants. And both sites experienced a severe drought from late 2015 to early 2016. So we collected data on plots at both sites before, during, and after the drought. And we counted all trees over 5 meters in height on these plots. And then to look at the effects of drought and elephants, we used the ratio of remaining trees pre and post drought. So the number of trees at time t over t minus 1. And we looked at the effect of drought periods or pre post drought, the effect of elephants using site, and we looked at density dependent effects using the number of trees on the plot at the start of the period. So we found that, as we expected, both drought and elephants had a negative effect on the ratio of remaining large trees. And there was an interaction between these factors, but it was in the opposite direction that we expected. So there's actually a larger effect of drought at the site without elephants than the site with elephants. We also found a large effect of density dependence. So the more trees we had on a plot at the beginning of the period, the lower the ratio of remaining trees was at the end of that period. So while we did see an interaction between drought and elephants on these trees, instead of seeing a synergistic interaction as we expected, we saw an antagonistic one. So we don't have any evidence of elephants foraging more or creating more damage to trees during the drought. Instead, what we saw could be the result of several causes, including increased competition among the trees at the site without elephants, where the consumers aren't present to maintain low densities of these large trees. So drought could have a greater effect on these trees by further increasing competition for water. So while savannas are generally thought to be primarily consumer controlled, with herbivores being the primary limiting force for these large trees and maintaining open canopies, we see here that climate can also play an important role in this woody vegetation structure. And drought, in combination with density dependent factors like competition, can maintain low density, can reduce densities of these large trees and maintain open canopies in savannas. So with that, I would like to thank our collaborators and our funding sources, and thank you all so much for listening.